Hello lecturers, my name is Danial Waldan Amani bin Wandesral from E0T251, tutorial group TE17, and my article is titled, Why is Filial Piety Changing in Singapore? In my article here, you can see that the claim of its population mean or the null hypothesis is that the average size of households has become 3.09. This is a recent claim, so I am here to test if it still holds true. The alternate hypothesis is that the average size of households is not 3.09. The reason is because the objective of my hypothesis test is to determine whether the true population mean differs from the claim made in the published media. This is a two-tailed test because we are checking for any difference, whether the mean is higher or lower than 3.09. Here's my sample data of 30 points collected from my Google survey. It is suitable to test the claim because my target audience are of course residents. A sample size of 30 allows the sampling distribution of the sample mean to be approximately normal, even when the population standard deviation is unknown according to the central limit theorem. Also part of the given info, my significance level is 5%. The mean of all my sample data is 5, where I use the average function with the range of my sample data cells in the brackets. As you can see, first cell which is B4 to the last cell F9. Similarly, to find my sample standard deviation, I use the standard deviation.s function which also has the range of my data cells. Why I don't use the standard deviation.p function is because I do not have an entire population. Using the standard deviation.s function allows me to estimate the population variability and is required for a t-test where the population standard deviation is unknown. Next, finding my test statistic, I'm using a t-test which measures how far my sample mean is from the claimed population mean in terms of standard errors and because my population standard deviation is unknown. The numerator is the difference between my survey mean and the claimed mean. The denominator is the standard of error of the mean which adjusts for my sample size. My hypothesis is two-tailed, so I need a two-tailed p-value. To find the two-tailed p-value for a test, absolute t-statistic, which is cell n6, ensures the test accounts for the sample mean being either higher or lower than the claimed mean. Degrees of freedom is the sample size minus 1, which in this case is J7 minus 1, which is 29, which adjusts for the size of the sample, which affects the shape of the t-distribution. The p-value tells you the probability of observing a sample mean as extreme as mine, assuming the null hypothesis is true. Lastly, to find the margin of error, this gives a range where the true population mean is likely to fall based on my sample and chosen confidence level. Inside my bracket is the significance level, the sample standard deviation, and the sample size. This formula internally uses the t-critical value and the standard error of the mean. The 95% confidence level for the population mean is calculated as sample mean minus margin of error and sample mean plus margin of error. This interval provides a range of plausible values for the true population mean, which is mu. The sample mean is the best estimate of the population mean. The margin of error accounts for sampling variability because if you took another random sample, the mean could differ slightly. By adding and subtracting the margin of error, we create a range that likely contains the true population mean. Therefore, based on the t-test and the confidence interval, we reject the null hypothesis and conclude that there is sufficient evidence to suggest that the mean household size in Singapore is significantly different from 3.09. Thank you.